The dBMacros are various tools that automate the repetitive tasks involved in processing the results from sound level meters. Essentially, they're designed to help you get as quickly as possible from raw data files to professional-looking graphs with custom calculations and even audio playback. A license or free trial is required for all of the tools that are discussed in this video. However, there are various Excel functions included with the add-in that are completely free. For more information about these, check out the online guide. To install the add-in, first head to the Downloads page and get the latest version. Make sure that Excel is closed and run the installer. Now, every time you open Excel, you'll see a new ribbon tab. Also, some new keyboard shortcuts will become active and the free functions will be available for use. When you try to run a macro without a license, this pop-up window will appear. Click Activate to start a free trial, or if you have a subscription to dBMacros, then hit Generate License key and input the key before clicking. In order to function correctly, the macros will expect certain things about the data in the Excel file. First, that every spreadsheet groups a single dataset with one consistent time interval, for example, 1 second per row. Secondly, the data is arranged in columns, with the titles at the top. Most sound level meters already generate data this way. Next, the time data must be in the first column. And if you have spectrum data, it must contain HZ in the title alongside the center frequency value. You can quickly get your data to match these requirements by using the Import Data macros. Either click Import Folder, which will extract from multiple files, or Prepare Worksheet, which will run on the currently open spreadsheet. Let's run through an example. Here I have opened a raw data file. You can download this file yourself from the link in the description. It is a text file generated by a sound level meter. I'll click Prepare Worksheet and choose the Raw Data option. Use this option if your device is not listed. This brings up a pop-up to select the header row, the first data row and the time column. As you click the different inputs, the area on the sheet will be highlighted. In this example, the header row starts on row 9 and the data starts on row 12. Time data is in column B. Click the button and follow the prompts as the data is checked to meet the data layout rules. Also keep an eye on the status bar for information during processing. Now the data is ready, there is a prompt to generate a graph. This is the same behavior as clicking this button. First, there is a prompt to choose where the graph will begin and end. The top half is where we can modify the start and end times manually. The bottom section has a list of all the time periods on the datasheet. Here, the word period refers to a block of data with a gap after it. It's used a lot, so it's important to understand its meaning. The example raw data we're using has a column titled period, which is simply the row number. But when the dBMacros use the word period, and when I refer to it in this video, the word is referencing a single block of data. During the Prepare Worksheet step, we got a prompt telling us that there was a single period recorded. Here you can see the single period listed with its start and end time. Let's plot the whole hour of data in our graph by hitting Apply. Next we have the Series Selector. This has all the sheets listed in the top half and the data columns listed in the bottom half. The spectrum data columns are hidden until this box is ticked. Select the data to be included on the graph and hit Create. Input a title or load from previous titles using the history below. When this checkbox is ticked, the date will be added to the title automatically. The generated graph is on its own tab, color-coded to help us differentiate between data and graphs. As with everything, this is simply a native Excel feature that you're free to modify. Time is used for the x-axis. You can see the data starts at 11 PM and ends at midnight. The y-axis is showing decibels. The min and max values were calculated automatically. We can modify these x and y axes with this button here. This toolbar has buttons to shift up and down and left and right. Or we can set the y-axis manually, or get back to the previous pop-up with this button here. After generating a graph this way, there'll be a prompt to split the graph into shorter periods. This is the same as clicking this button. The splitter will give various options for dividing into shorter periods. The top section is a simple division using fractions, for example, dividing into quarters. If there are any gaps in the data, which means the graph is plotting multiple periods where the sound level meter was stopped and started, then this button will split at these gaps. If there are not any gaps in the data, then the graph is plotting a single measurement period and can instead be divided by time. For example, here we can specify 15 or 5-minute graphs. Let's choose 15 minutes. This generates 4 graphs from the 1 hour original. There is this option to split a line to the period start or to sync the change in time with the clock. For example, regardless of when it begins, our 15-minute graph would be split at exactly 1/4 and 1/2 the hour. Choose how to name the sheets, either by using a numbering system or the start time. This checkbox will keep the original graph, uncheck to keep only the split graphs. Click Apply, and the sheets have been renamed to match the start time of the graphs, as this option was selected. Hopefully you can see how useful it is to manipulate the data by using the time column for reference. It's also possible to synchronize multiple sound level meters on different sheets so that they have matching time columns and can be aligned all on one graph. Let's try this now. I've got the data for another device here. I'll prepare it in the same way as the last one and then copy the sheet into our previous workbook. So now we have 2 data sheets, one for each device. To time align these sheets, I'll use one of the macros in the Toolbox. This button opens the dBMacros Toolbox, which has all of the available macros listed and arranged by what they do. The top green section is for handling worksheets, and the bottom yellow section is for dealing with graphs. We'll go over a lot of these later on. For now, we're interested in the Sheet Master Time button here. Hover the mouse over the button to read more about it. This one instructs us to select the sheets we wish to align and then run this macro. One way to select multiple sheets is with the Control key held down. However, you can use the new keyboard shortcut Ctrl-Shift-A to select all sheets of the same type as the active sheet. Now our sheets are selected, we run the macro. This adds a master time column on all the selected sheets and then aligns the data to this column. Now when we bring up the series selector, the time-aligned sheets are already both selected. It's guessed the data series to plot on the graph based on the titles. Let's generate it. It's also easy to modify the graph by again using the series selector. You can bring it up with the shortcut key Ctrl-Shift and M. And you can see it has selected the series found on the graph. Another way to add a new series to an existing graph is with the Quick Add Series pop-up. Click this button here. We can only add a single series this way, but there are more options for the look of the series. For example, you can specify the line type and color. Also, customize the name. If you add a series this way, you can quickly add it again on another graph using the keyboard shortcut shown here, Ctrl-Shift and R. You can even select a few graphs and it will be added to all of them. The new series will be shifted to align with the same start and end times of the graph. This button here is a way to quickly add a new column of values for use on the graph. Here you can choose to either calculate a level based on an existing column of data, for example the LAQ, or you can generate a single value for the entire column. The drop-down list has all of the columns available on the datasheet. There are various functions to choose from that will be run on the data, including new decibel functions included with the add-in, such as a dBAverage to calculate a new LAQ. The results can be inserted as values or as formulas to be recalculated again in the future. The length option specifies how to fill the column of values. Selecting period will calculate a single value for an entire block of data. It's also possible to calculate a new value at time intervals, such as every 5 minutes. With this, there is the option to either align with period start, that would be every 5 minutes from the first row, or sync to time change to align the intervals with the clock. Let's generate an LAQ for every 5 minutes. It will use the dBAverage function included with the dB functions. For more information about this function, check out the page in the description. Select to calculate for every 5 minutes. Customize the title and click Apply. Now, the new calculated LAQ appears in our series list. A recommended color and line type are already suggested. This feature can also be loaded by clicking the Add Series button while viewing a datasheet instead of a graph. The newly added line is showing the 5-minute continuous LAQ levels in the column of data that was calculated and added to the datasheet. To display the decibel value of these types of continuous lines, click the Add Values button. There are many options for the design of the value label shown in the pop-up. Now it's time to start analyzing data and running calculations. For this, there are the click tools. These give us various options for interacting with the active graph. The options in blue on the left are for handling single rows of data and are activated with a single mouse click. The options on the right are for handling multiple rows between 2 clicked points. As the macros were able to detect the spectrum columns on the datasheet, these can be used to generate spectrum graphs. Select View Spectrum and click on a point on the graph. It brings up the spectrum pop-up window and highlights the point we're looking at in the graph in the background. At the bottom is a table of values in third octaves, if they're available, and whole octaves. As you hover over the bars, the corresponding value is highlighted. You can click on the bar to temporarily add this frequency band to the graph in the background. To view the spectrum at a different location, click the graph in the background at the desired point on the line. Above the graph are various options including step back or forward 1 row, switch to show lower frequencies, display the octave values, await the spectrum values, change the display, and make a spectrum graph. Let's do this last one. Now there is a pop-up window with various options for generating the spectrum graph. It can be inserted as a mini graph in the corner or generated on its own tab. It's important to remember that this is only ever automating Excel's native features. Once generated, these graphs can be edited manually and shared with others who do not have the add-in installed. There is the option to label the peak that we have added. We'll discuss labels later in the video. The Modify Graph Range toolbar will not work on mini-graphs, but if we have our spectrum on a separate sheet, then these step buttons will shift the current spectrum row, and also update the title with the new time. The Set X-axis Range button can be used to modify the start and end frequency bands from those available. Another difference when viewing a spectrum graph is that the Add Series feature shows a list of various sources such as the DEFRA low frequency noise curve. These options are taken from the spectrum library file that is installed alongside the add-in. One of the most powerful tools in the macros is the levels calculator. This will run calculations and generate results between 2 points rather than on the entire column. You can bring up the calculator either by clicking the start and end points on the graph, or with this button on the ribbon, which will run calculations on the entire graph. The top shows where the calculation starts and ends. Below, 4 calculations have been made. These are calculations based on the LAQ series shown here. There is a decibel average for the whole period, the maximum value, and the L10 and L90 percentiles. The functions used for calculating can be chosen from these drop-down lists. This button will save the calculations to a new results datasheet. However, the Add Line feature allows a single value of choice to be added to the original datasheet and plotted as a new series on the graph. The chosen calculation is highlighted in white and can be selected either by the drop-down list or by clicking one of the calculation results. The title text and color of the new series line can be customized. When the Add Label checkbox is ticked, there is the choice of showing the value over the line and including a label with arrows. Here you can see the result which was added to our datasheet and then plotted on the graph. The calculator will also run calculations on the valid spectrum columns. This area is similar to the View Spectrum pop-up window that we looked at before. This includes a similar button to generate a spectrum graph, which will save our results to a new datasheet and give the same options as before. There is also a section for calculating a sound power level based on a reduction by distance only for each of the octave band values. This uses the sound power function included with the dB functions. Once a distance is provided, the options are loaded. This button will send these calculated values to dbmap.net to get started with noise mapping. The graph now has 2 labels, one for our mini-graph and one for our calculated level. Let's look at how to add our own labels to events in the graph. There are 2 types of labels available, single labels and long labels between 2 points. Single labels are usually for identifying peaks. Long labels are for describing periods of activity. Either option will bring up the Add Label pop-up window. Enter the label text and hit Apply. While the form is open, the label text or design can be modified. The label builder will reuse a label from the saved history, either by replacing the current text or adding to it. There are various buttons to add text, such as surrounding in brackets, and at the bottom is a word cloud of all of the terms previously used that can be clicked on. All of this is intended to speed up an otherwise slow process of retyping the same terms. If you're happy with your label, then close the window. This checkbox here will automatically close the window when you click OK. However, while the window is open, click other points to add or edit the label at another point. This is useful if you have a few peaks you wish to have the same label. If Auto is toggled, then the current label will be automatically applied to each peak clicked. These labels use 2 native Excel features. The first is series data labels, which are connected to the series itself. The second is with drawing objects, which is how the arrowheads are drawn. These objects are separate from the series. As they're native Excel features, you're free to manually edit the position and text of the labels. However, bear in mind that the labels are also saved to a column on the datasheet for use with other macros. For this reason, the best way to edit a label is to click on the label, or the same point, and follow the prompt for editing the existing label. From here, modify the text or clear it, and the datasheet will also be updated with the changes. Otherwise, if you manually edit the labels, then you should update the labels column with these changes. After this, the Add from Datasheet macro will add these labels to other graphs. Modifying the start or end times of a graph will prompt to automatically redraw the labels this way. Let's look at the other click tools. This one will remove a peak by clicking on it. The column will be duplicated and the data for the peak will be cleared. There are narrow and wide options for removing peaks, which use two different methods for determining the start and end of the peak. This other click tool will remove between two chosen points on the graph. If we'd previously chosen to save as formulas, then this recalculation will be done automatically. This won't have excluded the spectrum data, as this would need to be removed manually. The next click tools can help us with this. This one allows you to click on a point and go to that exact cell on the datasheet. The next option will highlight all the cells on the datasheet between the 2 points we click. Next, we have another way to modify the start and end of the graph, either by splitting at a point or trimming the graph to fit between the 2 clicked points. Use this to zoom in on a particular event for analysis. The macros were designed in-house at a UK-based environmental health consultancy, dealing primarily with noise nuisance, and as a result, a lot of the development has been focused on the guidance of BS 4142. One example is the common use of the LA90 for determining the background noise level. For this reason, the macros will guess that the LA90 should be plotted on a graph. Another example is calculating the impulsivity of a noise event to determine the rating level. To do this, select the click tool, click 2 points along the rise of the peak of the noise. The area calculated is highlighted on the graph, and the start and end points can be adjusted, or alternatively, custom input values can be used. Add this result as a label on the graph, or click Save to Worksheet to keep this result and see a breakdown of the calculation. Let's look at other useful calculation features. This button here will use a template for plotting spectrum data on a graph of the noise rating curves. Remember, after making changes, you might need to refresh the workbook by hitting F9. Another useful macro for calculation is this button labeled Distribution. This will give you useful information about any selected data. For example, select the column of LAQ values and hit this button. A new datasheet is created with a results table and a bar graph highlighting various statistics about the data, including the mean, median, and mode, when rounded to whole numbers. You can delete statistics you're not interested in, or even cells of data, and click the button again to update the graph with the changes. When you're happy with your results, you can print and copy the graphs to your reports. One simple yet useful macro for this is the Copy as Table button that will put the plotted values onto the clipboard. This way you can paste the data table into your report alongside the graph, or even view it as a web graph, which is a feature that will be looked at in Part 2.